Alright guys, I've got a pretty exciting one here. Stayed up all night last night and haven't gone to bed yet, so a little bit whacked out. Bear with me, but this is really awesome and I'm really excited about it. Basically what's going on here is we're taking two arrays and we're organizing both arrays off of one array. So to make that, to kind of get you to understand that, imagine if we have a manager that wants to enter, like with this program, he's going to enter an employee name and how many sales that employee did that month. And then he's going to be asked again for a new employee and their sales, and so on and so forth. Well, all of those employee names are going to be stored into one array, and the employee sales are going to be stored into another. And we're going to organize the sales, the one that's storing all the sales, we're going to organize that from greatest to least. Greatest at the top, least at the bottom. But we want the one with all the names in it to also be adjusted so someone's not getting credit for someone else's work. They're getting credit for their work. So the corresponding spots need to be adjusted when the sales array is adjusted. So everything's kind of paired and it needs to stay with its pair. So this, we'll say the new Boston, this guy's channel, he does a really good job of explaining lots of things. I've watched several of his videos and I think he's very detailed. It's very simple. So I highly encourage you to watch some of his videos. There's good tips in there. There were a couple of things that I was iffy about with my own program and I didn't know how to do, and watching that kind of cleared things up. After that, I still had to do a load of work. This still took a lot of time, a lot of thought, a lot of newness. I do think I believe he's coding in C, and this is in C++, what I have here. I'm not, there's slight differences. And with this video sorting arrays that he has, I think he's sorting one array, if I remember correctly. This, we're going to be sorting two corresponding arrays. So it's going to get a little bit more complicated. So it did take a lot of thought even after watching, but he definitely helps things become more clear. So I liked the delivery, the communication, being simple yet being detailed, and not saying, if he said anything complicated, like a complicated word that I didn't understand, he would define it, and show you what it meant. So what we have here, I'm going to go ahead and run the program. I want you to see it work, so you don't get to the end of the video and say, oh, that's not what I needed. We'll go ahead and knock that out real fast. Enter first name. So this is going to be our first employee, Eric. His sales, let's say 56. Tim got 34. Yoshi's on the team. Yoshi always does really good. He tops the charts. And let's see, Kim's got 78. Let's do a Greg. Greg did 44. Okay, so now what's going on here is I want to allow the user, let's say it's a manager, I want to allow the manager to decide how many of these slots in each array get filled. So the programmer, he programmed this long ago and he left. He doesn't know what's going to happen in the future. The manager may have lost employees. He may have gained some. So we're not going to say that this array has these elements inside of it. We're going to leave that up to the user to decide how many of those spots get filled and what they get filled with. So that's another really awesome thing that I'm really happy about with this. I will note that this does not make use of structures, classes, vectors, though I do want to look into vectors. Kind of interested in that. And it doesn't make use of swap or sort function, which is really cool. It's just an array, another array, and what would be known as a bubble sort method. So anyway, all of this is done with a do while loop. So I've got a sentinel value, and that sentinel value is end, as you can see here. Let me go ahead and scroll down the page as well. Oh, yep, Creative Cloud, cool. So we've got, that. Just want you to be able to see the code as well real fast before we go ahead and run this. So end is the sentinel value. I want to go ahead and output all the information now. And awesomeness. Look at all of that. That just makes me very happy. 90, 78, 56, 44, 34. It's all organized. I'm ecstatic. But we need to make sure that this also was organized accordingly as well. Did Yoshi, was he the one that actually did 90? Did I type that in? Well, yes, I did. Cool. Kim, 78. Yep. Eric, 56. Where's Eric? Yep. Greg, 44. Cool. And Tim at 34. That is amazing. I'm so happy. And it's very simple. Well, sort of. So now you see kind of what this program produces and what we're trying to aim for here. So I'll go ahead and Command K and Shift Command Y if you're on a Mac and you're using Xcode. And now we'll run through the variables here and get started. So we've got two headers here. I just want to have these, as you saw in the program, for it to be organized, look nice. That's all that is. We're going to have this as it's going to mean whichever slot we are in any given array. So for example, it could be name array slot 0, or name array slot 4, or sales array slot 3, element 3. I think they're called elements, but slots, sections, and mixes with my brain better. So we're going to have that. Now we do have to declare another counter. This is going to keep track of the total amount of employees we're going to enter in this input area. So this is really the only area that the user is going to interact with. We need to keep track of how many employees we're trying to check for. So that's where that comes into play. This is a counter as well, but we can't use this to keep track of the total amount because at some point we're also going to use this to check like a for loop. And we're going to have to reset this to 0. So we would lose track of the total number. That's why we need another counter for the total number of entries, or first name sales pairs. So now we have a variable for name. So we're going to enter the name there, and we've got a name array at 20. What this would basically be, if you were to take away that semicolon, is it would be something like this. When we go through the loop the first time, we would be asked for a name, we would enter it, then it would be stored there. So it's being stored in the first slot, which is 0, because they start at 0. Then we go on to the sales, we do the same thing with the sales. We come back around and see it increments by 1, so now it's sales array number 1, which would be slot number 2. We're asked for it again. We enter a name. Maybe this guy's Tim. We go to sales, do the same thing with sales. Increment by 1, now it's name array 2, which is the third slot. We got Fred. You see how that works? And then let's say we only have 3 that we entered, and then we end sentinel value. So that's what would be stored in there. We still have 17 open slots there, but we're only using 3. That's basically how that works. We do have this name T. It's a temporary holding variable. That's going to be useful whenever we go in to organize the arrays. This has to be in there. I'll show you in a flowchart on the other page when we get to that, why that's so important. Then we have sales, the same thing with sales. Sales array, it's basically the same thing as up here name, temporary holding variable. The reason that there's 2 of these, if all of this was declared, like all of your entries were integer here and they're not string, like if that was, you're only going to be typing in 2 things. If that was also integer, you wouldn't have to have 2 separate holding variables here. It would just be like temp. A lot of people call it temp. and we can make use of that. The only reason why there's two of those is because when you go to make those switches, you can't switch like this with something that's declared integer with something that's declared a string. It won't let you, so that's why there's two there. So moving on, we've got the first time we're going to interact with the program. Do, enter first name. Enter that name. Name goes into 0 here in the name array. Remember up there we demonstrated that. Now, if name array, which you just entered into slot 0, is not equal to n, you haven't hit the sentinel value, you're going to ask for sales. The reason we do that is because if I want to be able to exit immediately. I don't want, after I hit that end, I don't want to be asked sales. I just want to exit out, and I don't want to really be storing anything, or I don't want that to be output either. So if it's not, then we ask for sales. The same thing goes with sales. Sales gets put into slot 0 in the sales array, and then we increment I. We also increment the counter, so the counter would be, counting as well. Now, if you do hit the end there, the sentinel value up here, it'll know it down here, and it'll take you right out of that do while loop. Okay, so all of your inputs are done. Now we move on to the important part of this program. This is the hub here. This is where everything is really important and everything that should make you very happy about this program. We're going to start with a while one here, and the New Boston, the guy up here that I was telling you about, he explains this as well. Basically what's happening here is while one sends you into an infinite loop. And we need to have that, and I'll show you why when we get to that flowchart. So once we get into this loop, we're going to have swapped is assigned to 0. The reason we need this is because we need a way to get out of this infinite loop. This for loop will not allow us to do that. The if statement won't. Only this, we have to create a situation to where we can escape from this loop when we want to. So it's going to be equal to 0. When it's equal to 0, we leave this while loop. We can get out and we can start outputting information. So it's assigned to 0. We're going to go into this for loop now. So I is going to be reset. Remember, that's why we need the C here. Otherwise, we'd lose total count. So I is going to equal to 0. And 0, as long as 0 is less, or I, whatever I happens to be in the moment, as long as that's less than the total that's been counted, minus 1, and then I incrementing by 1, I plus plus. Now the reason this is, the total counter minus 1 is that over this we've counted 7 people that we're going to enter. Like in this flowchart on the other page, I've got a demonstration where there's 7 entries. Now, all of this information, what this does is it compares 2 of those slots. So in one array, it's going to compare, and specifically here, if you can look here, it's going to compare elements in the sales array, and it's going to compare the ones that are side by side. So it's going to start with 0, and it's going to do 0 plus 1, so slot 1. So it's going to compare 0 and 1, both those slots. So whatever's entered into sales array element 0 and sales array element 1. Each time we go through the loop, it's going to check for that again. It's going to increment, so it's going to be 1, so it's going to be 1 and 2, and then 2 and 3, 3 and 4. So we have 7 people. Let's say we get to that 7th person. It always wants to check against another element. Well, that would be the 8th person. Doesn't make any sense because that's blank. If you did that, you might output something weird, or maybe a blank line, or it's not good. So what you want to do is you want to end the checking at the element before the last one. Because think logically, once that happens, once the second to last one checks against the one after it, the last one, then everything's in order, you know? So you don't have to go to that last one. That's why there's a -1 there, because we don't want to check against a blank slot. So I like to imagine these as pieces of paper, and I have the guy on top, you know, the employee right here on the top sheet of paper, and he's got maybe like the number 50 in his sales, and then I flip over to the next sheet and I say, oh, that guy's got 70. So I pull him out of the stack and I put him on top. And you go down the list doing that. So that's what's happening here. So if 0 slot, whatever's entered into there, is less than this, you know, the next slot over, 1, then we'll do all this. And this is our temporary holding variable here, sales T. And what's going on is we're moving this over to here. So whatever information stored in there is going into here. Now this is empty. So we can move whatever information is stored in here over to there. It's in sales array I now. Now this is empty. This is empty. So we move the sales T, whatever information is stored, we exchange that. And sales T goes back to being empty, and everything is moved around appropriately. We'll end up doing the same thing with name so it sticks together. And then we'll take swapped and assign it to 1. So that, you know, after we go through the loop until it finishes, it's going to check against this and be false. So we'll go back to the while and come back again. Now let's go over to the flowchart and let me show you why this while is so important. Because you may be thinking, well, I could just do a for loop and go through all the selections and be done with it. I mean, that's what a for loop does. It checks for everything. It goes through all of the, you know, the max, from the minimum to the maximum. This is why it doesn't work. Let's look at this little diagram here. Okay, so to start, we're going to check sales A I against sales A I plus 1. So I equals 0, and I plus 1, 0 plus 1 equals 1. So we're going to check these two values against each other. If this is less than that, remember, this is less than that, which it is, then we're going to do that, you know, all those equations inside of there. We're going to do all of these. So we're going to start with sales. This is our sales array here. So let me go ahead and I'll actually type this in too. So 0, so 0, 1, 0 and 1. The reason we need that temporary value is because if we took that line out, take this out, then all you're doing is exchanging 1 and 0. So this is what happens. It gets overwritten. You lose it. Can't do that, obviously. So we have to have that temporary value. This is what happens. A circle. Move it into the temporary value, or variable. Move this over. Move this up. That is exactly what those 3 lines do. Did you see that? It was like a circle there. So if you can envision that, you can do this with a deck of cards, and I'll show you, when you do it with a deck of cards, or when you do it like this, you'll see that you need that outer while loop, that infinite outer while loop as we go along. So we also, remember, we have to do the name as well. There we go. So temporary variable, move everything around in a circle. There we go. And now we assign swap to 1, and we increment I. So swap 1, increment I by 1. I is now equal to 1. I plus 1 is 2. So we do 1 and 2. So we compare these two now. Well, yes, that's less than that. So let's switch it. Temp variable, move this over, and then move this up. Do the same with name, remember? Now we assign swap to 1, and we increment I again, so it's 2 against 3. 10 is greater than 9, so we have to do this again. We're going to end up getting 9 all the way to the end. I should have planned this a little better. This will probably end up being 20-something minute video. So yeah, swapped is assigned to 1 again, increment I, 3 against 4. There you go. Have to do the name as well. You're probably noticing something now. We're getting to the end of the for loop here. And you're like, I could have just done a for loop. I don't need that outer while loop. We can just do this and it's going to check for everything. It's going to go from, least to greatest and we're going to be set. Well, look what's happening here. Now we get through the while loop again. Last one, because 7th, person, the counter, -1 would be 6, which would essentially be the 5th slot. So we're going to stop here. All right, exit the for loop. Imagine if there were no while loop there, swap wouldn't even be there, it wouldn't matter. So we'd exit the for loop because none of this matters anymore. I has reached its limit at 6, which would be slot 5. And so we exit, now we output. So that's what's going to happen. Output all of our information. Does that look like something that you want to output in greatest to least? No. That is still horribly out of order, and exactly why we need that infinite outer while loop. That is not in order. So what happens is that swapped is assigned to 1 on our last run around. We go back, this doesn't apply, we don't enter the if statement. Swapped is still assigned to 1, so this is false. We can't break out. We go back to the while loop, assign swap to 0 again, run the loop all over again, starting from 0, comparing to 1. Eventually, you see, we're going to have it in order. There we go. Oh, this needs to be exchanged. So you see, I didn't have to do that one because 14 was greater than 10, so we didn't go into that if statement. And so you'll see, as we go along, eventually that's going to be in order. Once it's in order, swapped is equal to 1, swapped is assigned to 1. We go here, can't go into the for loop again, so we exit, false statement, enter the while loop again, swapped is assigned to 0, enter the for. None of this will apply because it's all in order, so we never assign swap to 1. Go through the for loop all those times, it's never assigned to 1. So this is true, we break out of the loop. So that's how you organize this whole thing. And that's why this outer while loop is so important. So I hope this diagram right here, I hope that, or flowchart or whatever you want to call it, I hope this really helps. The colors are fun, the bold text is fun, and you can do this with a deck of cards if you want. And you can change these values. So when we go to output the information, it's going to all be in order. I've just got headers here. I've spaced them apart to make them look nice. For resetting I to 0, the counter is still at 7, so I is less than 7. And then we're going to output each time. We've got name array slot 1, again slot 0, slot 1, slot 2, and we keep outputting until we are finished and we end the program. So that is basically the setup for two corresponding arrays, keeping all of the paired information together without using structure, without using class, without using vector or sort or swap or any of that. I do have another version where I did make a structure, but then looking at it, it was like divine inspiration, and I was like, oh my goodness, I don't have to have, I didn't have to have any of that, so I ended up modifying that down to this, and it was a very, very happy day. It made staying up all night awesome, and it's a lot of fun. So I really hope that this video has given you something useful. Hopefully you can apply this to something. I'm ecstatic about it. I'm really happy. I'm half asleep, and this is great. So anyway, thanks for watching, and I'll see you in the next video.